And we are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of every problem of lead code and geeks for geeks within less than 5 minutes. Okay, so today's problem of the day is insert and search in a trie, which is a medium level problem. And I also think it's a medium level problem. But due to this trie, like this trie is a very horror word I will say, and due to which a lot of people get horrified by the trie question. But it's very easy. What's trie? Trie is basically an array tree. An array tree. So look, as we all know, in each of the nodes in a binary tree, there are two things: left, right, and value. Okay, but what's there in a trie? What's there in a trie node? So in a trie node, instead of two things left and right, it has an array of children. So basically, in binary tree there is only two children, but in trie node there are 26 children. There are 26 children, we can say, of one node. Okay, and then there is one boolean keyword attached to it, that is end of word. Okay, so basically these are two things. So each trie node has a children that is of 26 length array. Okay, and one boolean. Okay, and there is one constructor you can see, which is used to initialize the values, like every child of its of a trie node has initial value 0, as initial value is null. Okay, and the is end of word is false. Okay, all right, so let's find out what we have to do in this. Now I think trie will be clear, so let's find out what we have to perform in this problem. So we will be given one trie node root. So it's very simple, it's not complex thing to do. So we will be given one trie node root and we will be given one key. So we have to insert that key is basically a word. So we have to insert that word into my trie node root. Okay, and after that, like we will be, and there are two things. One more thing is we have to search few things into my trie node. So we will be given one trie node root and I have to find out, oh, whether this key is present in that trie node or not. Okay, whether this word is present to trie node or not. All right, so yeah, that is it. So let's say we will be given this trie node. It's basically very visualizing thing. So da is present, I will give 1, and otherwise geeks is not present here, so I will return 0 in this way. So I think a small part of the problem will be clear. So let's jump onto the node section where I've written something for you, and after that this problem will become crystal clear to you. Okay, all right.
All right, let's see. So basically, what's a trie? It's an array tree which we use for storing and searching a specific string. So we can store that particular string into that, let's say, trie, and we can search that as well. Okay. So if you don't know anything, still you have no idea, you can check this out some articles on Geeks for Geeks. But let me try it first. So basically, look, if there is a binary tree, so can we use the binary tree to insert a number in the form of binary numbers like 0, 1, 0? 0, 1, 0. So if this is the number, how are we going to store it in our tree? So let's say first my node is this 0. So I will do something like, if 1, let's say 1 is the right side, okay, 1, and after that 0 is the left side. So something like this, 0, 1, 0. Okay, so can we say this is one number which we can use to, in this way we can use a binary tree to store a binary number. Yeah. So if suppose there is another thing 0, 1, 0, 1, 0, 1, 0, 0, so we can use it in something like this way. And after that, whether I have to check whether the 0, 1, 0, 0 is present into this tree or not. So we can say, yeah, 0, 1, 0, 0, it's present. So in the same way this trie works, but the alphabets are 26. So instead of 2 children, it has 26 children. Okay, so here I have tried to make a figure of a trie. So basically, look, it has 26 children and one boolean value is end of word. So suppose I have to insert, and look, all the values are null at the starting, null, 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 in this way. Okay, so I have to insert, let's say yes, I have to insert yes keyword. So what I will do, I will do something like this. Y is what? I will first of all get the index of y minus a, that is let's say 25th index. I will think 24th index it will be. So at 24th index I will, instead of null, so it has null, but instead of null I will make a new trie node at this. So trie node is what? Trie node is this. So now y is having one trie node. Okay, and that trie node has 26 values and is end of word. All right, I think you guys are with me till this point. Now y is filled. Okay, now y is not anymore null and it has this trie node. Now I will go at e. I will go at E to this y ka children. So y children at E is 4th index. So at 4th, instead of null, I will point one more trie node. I will make one more trie node. Okay. Now I will jump to, instead of, now I'm currently at this E. So I will do something like root is equal to root child A minus A, something like this. Now I have jumped to this S. Okay. So now instead of this S to be null, I make one more trie node here. So a one trie node and one is end of word. So is end of word will be true here. So like yes, yeah, it's end of word. Now suppose there is one more YET or YEA. Let's suppose there is YEA. So how are we going to, what will be looking like this? So at A also there will be a full trie node to fill if I have to insert YEA, and it will be having everything, and it will be also having one is end of word. Okay, so at this I will be doing yes. So YEA is also filled. In this way we are filling. Now I think that's clear. So now whether I have to search, how are we going to search it? Look, it's very simple. First of all, I will be given this root. I will check whether this 25th index, 24th index, y minus a, 24 index is filled. So yeah, it's filled. So I will say okay. Now take me to the this y is try nodes e is for fourth index. So I will go okay. Yeah, fourth index is also filled. Okay, great. Now let's suppose I am searching for YET. Okay, YET. So I will say okay. So I will now search to the instead of S, I will let go to this T index, but I will found null. Oh, it's null here. So it means YET is not filled. YET is not filled. But if I'm searching for YES, I will go at S and I will find oh yeah, S is not null. S has a one trinode. So S YES is present. But is YES a whole sentence? So I will check is end of word true? Yeah, is end of word is true as well. So it means there is a word present into this try with YES. Okay, so this YES end of word should be here true. Okay, for this try node it should be true. And yeah, that's it. That's it, guys. So in this way we are going to search. In this way we are going to insert. And believe me, the code for it is very very simple. So approach is very simple. Check whether character a minus a is null. Char minus a is null. If it is null, make a new try node. And if it is not null, it's okay. Because look, y suppose now I have to fill YET. So e will not be null anymore. E will not be null anymore. So E's children, I will make T as one more child node. Okay, but it will not be null. So if it is null, make a new try node. If it is not null, so directly jump to that and make a new try node. And at last, mark is end of word true. And for searching, same thing, traverse. And if you have not found the word yet, keep on traversing. And if you found null in between, just return false. And if you have got all the letters, just check whether is end of word is true. So yeah, it means that a key is present. Okay, all right. So let's jump onto the code section. The code will be very simple. And yeah, please subscribe the channel if you have not subscribed yet, and please like the video. Let's jump onto the code section.
Okay, let's write the code. So I'm writing the code and you guys will be too much amazed to see, oh, the solution of this try is very simple. How it can be that much simple? Okay, so let's go. So basically, I will be iterating this key for each character and I will be, let's use a for loop key dot to char array. Okay, something like this. And here I will check whether that node is null or not. Okay, so if root dot children of what? Key, ch, that character minus a. If it is null, make a new try node for this, as I already told. So instead of this is null, I will be making a new try node equal to new try node, something like this, and the constructor for it will make a try node by itself. Okay, and after that simply just jump to that. So now my root will be, instead of the iterating to this, so like we do something like root is equal to root dot left, I will do root equal to root dot children of this. Okay, something like this, and yeah, that's it. And after coming out of this for loop, I will simply do that roots is end of word is true, is end of word is true. It means that word is now inserted into the try. Now for searching, look, for searching is also very simple. Simply iterate to for the key. Let me copy this code here, something like this, and I will check if root dot children of ch minus a equal to null. It means that character is not present. Suppose I am searching for yes. I am searching for yes. Now at e I am searching for e children and it is null. It means e is not present. So simply that word is not present, I will simply return false. Otherwise that word is present. So now I will jump to that. Simply that root is equal to root dot left. I'm doing root equal to root dot children ch minus a, and after coming out of this loop, it means I have iterated this. So I will return what? I will check whether that is end of word is true or not. So if is end of word is true, I will return true, otherwise I will return false. Something like this. Because that initializing it will be false and I will be making it true. Yeah, that's it guys, that's it. Let's compile this. And I think I have done my full role in explaining you this solution. So yeah, let's submit this. And please subscribe the channel if you have loved the video, and please like the video and share your feedback to the comment section. It was a great explanation, I think, and I'm going to see you again tomorrow. Till then, keep on coding and bye.